Now we discuss about the laws of friction. Frictional force is always tangential to the surfaces and opposes the relative motion between the surfaces. This first law related to the nature and the direction of frictional force. When an object is sliding over other surface, the frictional force is acting between these two surfaces which are in contact, and the direction is opposite to the relative motion and tangential to the surfaces as are seen in the figure. And the second law is frictional forces independent of area of contact. Already we done an activity related to this which proves the friction does not depends on area of contact. And the third one is the frictional force depends on normal reaction. That means frictional force is directly proportional to normal reaction, or F proportional to R, or F equal to mu into R. This mu is the proportionality constant which is known as the coefficient of friction. Now we discuss the different kinds of friction. The first one is the static friction. What is static friction? The frictional force when the object is stationary, and the frictional force which opposes the applied force when the body is stationary is called static frictional force, and this is a self-adjusting force. If a body is stationary, the minimum force required to start the body to slide is called the limiting frictional force, and this is nothing but the maximum static frictional force between the surfaces. And the limiting frictional force is given by Fs is equal to mu s into R, where mu s is the coefficient of static friction, R is the normal reaction. To understand this idea, we take one example. Between two surfaces, the coefficient of static friction is 0.5, the mass is 5 kg, the value of G I am taking 10 meter per second square. That means a block of mass 5 kg is on rough horizontal surface. If we want to move this body, what is the minimum force required? It is nothing but the limiting frictional force, that is Fs. This is equal to mu s into R. On a plane surface, R is nothing but m into G. This is normal reaction, and Fs equal to 0.5 into 5 into 10. We get this is 25 Newton. Now to move this body, 25 Newton force is required. And now suppose we consider a force 5 Newton is applied. Can body move? No, the body will not get the motion. Body is not getting the motion. There is no change in state of the body. Then what is the net force? Yes, the net force acting on the body is 0. Applied force 5 Newton is there, but we are getting net force is equal to 0. That means a force which opposes the motion 5 Newton is acting opposite to this. Then only the net force becomes 0. Now in this case, the applied force is 5 Newton and the frictional force is 5 Newton. Now we consider when a force 10 Newton is applied. In this case also the body cannot move. Then how much opposite force is acting? 10 Newton only. Why? Because if this frictional force is more than 10 Newton, the body get a net force along this direction. But here the body is not moving means the net force acting on the body is 0. Hence we can say the frictional force is 10 Newton. Similarly, when you apply the 15 Newton, the net force acting on the body is 0. Applied force is 15 Newton. Frictional force is 15 Newton. When you apply 20 Newton, the net force is 0. 20 Newton is the force which opposes the applied force. When you apply 25 Newton, the frictional force 25 Newton. In this case, the body starts moving. When it starts sliding, the frictional force will decrease. Why? Because the static frictional force will converts into kinetic frictional force. That we discuss later. Now from these examples, what we can say? When you apply force 5 Newton, the frictional force is 5 Newton. When you apply force 10 Newton, the frictional force is 10 Newton. When you apply force 15 Newton, the frictional force is 15. When you apply force 20 Newton, the frictional force is 20 Newton. When you apply force 25 Newton, the frictional force is 25 Newton. That means the static frictional force is a self-adjusting force. You cannot give any particular value for the static frictional force between the surfaces. It is a self-adjusting force. It depends on the applied force. Now in this case, when you apply a force 25 Newton or more than 25 Newton, then what happens? The body starts sliding. The frictional force which opposes the sliding motion is called kinetic friction or dynamic friction. The sliding friction or kinetic friction or dynamic friction is less compared to the static friction. The question is why? Already we discussed the friction is due to irregularities present on the surface. Even though a surface appears to be smooth, if you see on the very powerful microscope on the surface, you can find some irregularities. When another surface is placed on this, these irregularities will interlock and we get the frictional force. When the body is stationary, this interlocking is strong. When body is sliding, then what happens? Since the time of contact is less, the interlocking is less, hence the kinetic frictional force is less compared to static frictional force. We can write Fk, this is the kinetic frictional force, and this is equal to mu k into R, where mu k is the coefficient of kinetic friction and R is the normal reaction. Always the static frictional force is greater compared to kinetic frictional force, or the coefficient of static friction is greater compared to the coefficient of kinetic friction. Apart from these two, we are having another kind of friction, that is the rolling friction. The frictional force which opposes the relative motion between the surfaces when an object is rolling on a surface. In the case of rolling friction, the rolling frictional force is written as Fr equal to mu r into R, where mu r is the coefficient of rolling friction, R is the normal reaction. Always the coefficient of static friction is greater compared to the coefficient of kinetic friction, and this is greater compared to the coefficient of rolling friction. Similarly, static frictional force is greater compared to the kinetic frictional force. This is greater compared to rolling frictional force. That means among these three frictions, the rolling friction is the less. During the motion, when a body rolls on a surface, it experiences a less frictional force. This is the reason why we are preparing the wheels to roll, the wheels in circular shape. You know, the invention of wheel, this is a great invention in the science. This changed the science a lot. And in case of rolling friction, the rolling friction depends on area of deformation and the radius of rolling body. That means when we observe this, when this tire in contact with the surface, at this position, the tire will be deformed as you are seeing. Here the tire applies some deformation force on the road and road applies some deformation force on the tire. And in this case, the area that deformed, that affects the friction between the surfaces. For example, if we consider a wheel with high air pressure and a wheel with low air pressure, in which case you can find more friction. Yes, the tire with low air pressure is having more friction. The reason is the area of deformation is more in this case. And the second thing is the radius of the rolling body. If we consider a scooter wheel and a bike wheel, whose radius is more? The bike wheel radius is more. The friction for bike wheel is less compared to scooter wheel. The reason is the frictional force is inversely proportional to the radius of the wheel. If the radius is increasing, the friction will decrease. Now we are going to discuss an example. In this example, you can understand how the static and kinetic frictional forces will act in case of a body. An object of mass 5 kg is placed on a rough horizontal surface. Between the surfaces, the coefficient of static friction is 0.5 and the coefficient of kinetic friction is 0.4. Now, you have to complete this table. This table is related to applied force, frictional force, and force used for motion. Applied forces are given. For different applied forces, you have to write what will be the frictional force and what is force used for the motion. Now in this case, already we done this problem. The coefficient of static friction is 0.5 means the limiting frictional force is Fs is equal to mu s into mg, or this is equal to 0.5 into 5 into 10, this is 25 Newton. 25 Newton is the minimum force required to move the body. When the body is in motion, the kinetic frictional force is acting. The kinetic frictional force is zero point 0.4, that is mu k into mg, mu k into r, that is mu k into mg, that is 0.4 into 5 into 10, we get 20 Newton. That means when the body is stationary, the limiting frictional force is 25 Newton. This is nothing but the minimum force required to move the body. And when body is in motion, that is when body is sliding, the frictional force is 20 Newton. Now you come to this table. When applied force is 5 Newton, then what is the frictional force? Already we discussed. With 5 Newton force, can body move? No. Therefore, the frictional force is 5 only. Why? Because the net force is 0. Here we are applying 5 Newton in this direction. When we get net force is 0, if the frictional force acting opposite to this is 5 Newton, then only we get the net force is 0. Therefore, the frictional force is 5 Newton. If this frictional force is more, the body move along this direction. If this applied force is more, the body will move along this direction. But the body is stationary means applied force and frictional force both are equal in magnitude but opposite in direction. Yeah, what is force used for the motion? 0 Newton. When you apply the 15 Newton force, yes, net force is 0, the body will not move, hence the frictional force is 15 and force used for the motion is 0. When you apply 20 Newton force, in this case also the body will not move, the frictional force is 20 Newton and force used for the motion is 0. When applied force is 25 Newton, the frictional force is 25. At this stage, the body starts moving. When body gets the motion, when you apply the 25 Newton, after some time the body will get motion, then sliding frictional force is converted into kinetic frictional force. In this case, if you go on applying the force 25 Newton continuously, the frictional force becomes 20 Newton. Since the body is moving, the frictional force is 20 Newton and here 5 Newton force is used for the motion. When you apply 30 Newton force, when you apply 30 Newton, yes, you can move the body. Since the body is moving, the frictional force is kinetic frictional force, that is 20 Newton, and the remaining force, that is 30 minus 20. 20 is the frictional and 30 is applied. 10 Newton force is used for the motion. When we apply 35, the frictional force is 20 and 35 minus 20, 15 Newton is the force used for the motion. When we apply 40 Newton, the frictional force is 20 and 40 minus 20, 20 Newton force is used for the motion. Suppose we draw a graph for this data, then how we get? Along x-axis I am taking applied force, along y-axis I am taking the frictional force. I am taking a graph applied force versus frictional force. For applied force 5 Newton, the frictional force is 5 Newton. For applied force 10, it is 10. For 15, it is 15. For 20, it is 20. For 25, it is 25. And for 30, it is 20. For 35, it is 20. per 40 Newton, the frictional force is 20 Newton. That means the frictional force increases with increasing applied force till the maximum value where the body starts moving. This maximum frictional force is called the limiting frictional force. This is nothing but the minimum force required to move the body. After this, the body comes to motion. The static friction is converted into sliding friction. So, the kinetic frictional force comes into act. The frictional force will decrease. As long as the body is moving, whatever may be the applied force, the kinetic frictional force is constant. That means up to this, the friction is self-adjusting. But when the body is in motion, the frictional force is constant. This is the graph which represents the relation between static and kinetic frictional forces. Angular friction. Suppose we consider an object of mass m is on a horizontal surface. The weight of the body mg is acting vertically down. The normal reaction is acting vertically up, as are seeing in the figure. If the applied force is acting along this direction, we know that the frictional force is acting along this direction. Now the resultant of normal reaction and frictional force is along this direction. The angle between these two is known as the angle of friction. The angle of friction is nothing but the angle made by the resultant of normal reaction and frictional force with normal reaction. This is the angle of friction. Now we discuss about the motion of a body along a rough horizontal surface. Suppose we consider an object of mass m is placed on a rough horizontal surface. A force F is applied. Due to this force, the object is moving with acceleration a. When it is moving, the sliding frictional force Fk is acting on the body. Initially, to move this body, the minimum force required is equivalent to a limiting frictional force. If the applied force is more than the limiting frictional force, then only the body can slide. Now we are considering the body is sliding. When it is in motion, the frictional force acting between the surfaces is the kinetic frictional force. In this case, the net force acting on the body is F minus Fk. This is nothing but m into a if the object is moving with acceleration a. Therefore, the acceleration a equal to F minus Fk by m. This is the expression for acceleration when a body is moving on a rough horizontal surface. Now we consider the body is moving on a rough inclined plane. Then what will be the expression for acceleration? Now we consider an inclined plane having inclination theta. When an object of mass m is placed on this, the weight is acting vertically down as are seeing in the figure. This is not normal to the surface. This can be divided into two components. One is mg cos theta, which is normal to the surface, and mg sin theta, parallel to the surface. The normal reaction acting on the mass is opposite to this, which is nothing but mg cos theta, and this component mg sin theta. This is parallel to the surface, and this is the component which helps the body to move down. If there is no friction, simply we can say the body can slide with the force mg sin theta and the acceleration is g sin theta. If the surface is rough, the frictional force is acting. Consider an object is placed on an inclined plane. Suppose we go on increase the inclination of the plane, then what we can observe? Now you take this activity. Suppose if object is like this, can it slide? No. If you go on increase the inclination of the plane, at a particular inclination, the body will slide down. Now this angle where the body starts sliding, this is called the angle of repose. Angle of repose is nothing but angle of inclined plane at which the body starts sliding down. Suppose we consider the angle of repose is alpha. If theta equivalent to alpha, angle of inclined plane is equal to angle of repose, then the body starts sliding. If theta less than alpha, the body is stationary. If theta is greater than alpha, the body slides down easily. Now I am considering the case theta equal to alpha. When theta equal to alpha, the body is ready to slide down. In this case, the pulling force acting on the body is exactly equal to the frictional force. In this case, we are taking the angle of inclination is alpha. In this case, we can write mg sin alpha. This is equal to mu s mg cos alpha. Mg sin alpha is the pulling force and this is equal to mu s mg cos alpha. This is the limiting frictional force. And from this we can write the coefficient of static friction mu s is equal to sin alpha by cos alpha and this is equal to tan alpha. And alpha, the value of alpha is tan inverse mu s. If there is no friction, simply we can say the body can slide with the force mg sin theta and the acceleration is g sin theta. If the surface is rough, the frictional force is acting. When the body is moving down, the frictional force is acting opposite to this component, opposite to the motion, and here the kinetic frictional force Fk is given by mu k into r and this is equal to mu k into mg cos theta since the normal reaction is mg cos theta. When the body is sliding down with acceleration a, the net force acting on the body is mg sin theta minus mu k mg cos theta. Therefore, the acceleration a equal to g into sin theta minus mu k cos theta. Suppose if the body is moving up. Now we try to write equation for acceleration when an object is moving up an inclined plane. In this case, when it is moving up, since the motion is along this direction, that is upwards, the frictional force is acting opposite to this. The pulling force of this block mg sin theta as well the frictional force both are acting opposite to the motion. Therefore, the minimum force required to move this body up is mg sin theta plus frictional force Fk. Therefore, F equal to mg sin theta plus mu k mg cos theta. If this force is applied, the body moves up with uniform velocity. Why? Because this is the minimum force required to move the body up.